Okay, so our learning intention for today is looking at scientific notation. That was our learning intention for the last lesson, but adding to that is now looking at significant figures. So when we're dealing with significant figures, there's a couple of things that we just need to bear in mind. All right, we are counting the significant figures from left to right, and you first start at the non-zero digit. Okay, that's where you first start. There are certain zeros that do not get counted. However, there are certain zeros that are important, and that's probably the part you need to understand with significant figures. They need to hold a particular place value within the question to be valid. So if we have a look at the first couple of examples in front of us in our key ideas here, as you can see, this question has 5 significant figures. So the 38,041, this 0 that's between the 4 and the 8, it is significant because if I removed that, it wouldn't be 38,041 anymore. It would be 3,841, which is not what we're looking at. And really, with scientific notation, the 0 that's between two numbers, integers, become significant. Whereas if we look at the next question, the zeros in front, those are not significant because when we put it into scientific notation, the two significant numbers are the 1 and the 6. So let's just put this into scientific notation to show you why the 1 and the 6 are significant and the 3 zeros are not. So if I was to jump, it would be 1, 2, 3. So I know it's going to be times 10 to the negative 3, and it's going to be 1.6. Notice that I'm using the significant figures, which is 1 and 6, as part of the scientific notation. Whereas the question above with the 5 significant figures, if I was to put that in scientific notation, 1, 2, 3, 4, it's going to be times 10 to the 4. So it's going to be 3.8041. Notice that I'm keeping that 0 that's between the 8 and the 4. It's holding the place value. Remember what I'm saying. It's holding the place value in your significant figure. Compared to the one below, when I take it out of scientific notation, you will notice that I will get the 3 zeros back. That's why they're not significant in putting it into my scientific notation. So, as I've discussed with scientific notation, looking at the third example here, this one has 3 significant figures. It's already in scientific notation, so it's a lot easier to identify the significant figures when it's in scientific notation, because we normally already get rid of those zeros that are insignificant. Now, this exercise is also about how we use our calculators. Now, depending on how comfortable you are with your calculator will depend on whether you want to use these particular buttons. Okay, you don't have to. You can always simply put 2.37 times 10 to the power of 5 on your own calculator. You don't have to use those buttons, or we'll still get the same thing. However, you do need to understand how to read the calculator on the screen if it comes up with significant figures, with scientific notation. So 2.37 e to the 5 means 2.37 times 10 to the 5. So now that you know this, that will give you an idea of what your calculator is actually saying. Let's look at the very first example together. It's asking us to state the number of significant figures in the given numbers below. Okay, so now let's remember about what I've just discussed with you about significant figures and which zeros are important and which ones are not. The 4, the 5 and the 1, they're all significant. So we would say there are 3 significant figures in the very first question. Notice that I've abbreviated. That's okay, you can abbreviate as well. It saves you writing out the whole words for both of them. Good, normally worth 1 mark. So with B, similar to the example that I went through with you above, The zeros are not significant. Those first 3 zeros are not significant. However, that 0 between the 5 and the 1, that is significant. It's holding that place value. If we remove it, it's going to change the question. So therefore, when I put it into scientific notation, I remove that 0 between the 5 and the 1, it changes the question. That's what you've got to keep remembering, is it going to change the question. So, but this particular question, there's 4 significant figures that we need to account for. Tick. Last but not least, C. When your question is already in scientific notation, the significant figures are just these 2 numbers that are left there with you. So the significant figures, there's 2 significant figures in C. All right. Hopefully you feel nice and comfortable with that. Let's go on to some harder questions, because example number 20 is probably the more classic type of question I would put in your test. It's now asking you to write these numbers in scientific notation and to 3 significant figures. So it's almost like I'm asking you to round to 3 significant figures. That's what it's really going for. So step number 1, I would always encourage you to write it in scientific notation first. Get that first step out of the way. That's what we've practiced in the previous exercise, so hopefully this part will be the easy part. So now we jump. 1, 2, 3, 4, 5, 6. 2.183 times 10 to the power of 6. Notice that obviously I've left those 3 zeros off. They're insignificant. I don't need to write them anymore because I've got it in scientific notation. The question has asked me, I need to put it to 3 significant figures. So once you've got it in your scientific notation, well done. Now I'm going to get it to 3 significant figures, like rounding. Count. That's significant. The 2, the 1 is significant, and the 8 significant. That gets me 3 significant figures. All right, you're moving from left to right. Draw your line down between the 8 and the 3, because we only want 3 significant figures. We don't want the 4th one. That 3 is now going to affect the 8? No, it's not. It's like rounding. It's just going to be simply 2.18 times 10 to the power of 6. So now you've achieved the second part of the question, was getting it to 3 significant figures, and you already put it into scientific notation, so you've made those changes that we asked you to do in the question. Well done. Okay, let's have a look at B. Same situation again. Get it into scientific notation first. So that's exactly what I'm going to do. 1, 2, 3. So I know it's going to be times 10 to the negative 3. 1.9482. Great. Scientific notation, ticked. Now I need to get 3 significant figures. Same as what I did in A. The 1 is significant, the 9 is significant, and the 4 is significant. I only want 3, so I have to get rid of the 8 and the 2 by looking at rounding. So I'm rounding this. That 8 is going to have an effect on the 4. So it's going to be 1.95 times 10 to the negative 3. Easy. What do you think? Could you do that on your own? Hopefully you're okay. It's worth trying and just seeing if you can have a go with the questions that get set. Good job. So that's significant figures with scientific notation. A little bit more about how to use our calculator. So when you're using your calculator, remember brackets are going to be your best friend, especially when you've got multiple different types of operations happening at the same time. For example, 21A, everything is multiplication. So the nice thing with this is you literally just need to type into your calculator 3.67 times 10 to the 5 times 23.6 times 10 to the 4. Have a go. Pop that in your calculator. See how you go with that. right. Now they want your answer left in scientific notation, and they also want it correct to 4 significant figures. Okay, so the answer you should get to 4 significant figures, hopefully you got this, 8.661 times 10 to the power of 10. Did you get it right? Give yourselves a big tick if you got that one right using your calculator. Make sure you know how to read your calculator and that you get the same answer that I did over here. Check with the person next to you if you're not quite sure how to use your calculator, because it does depend, different calculators can do things a little bit differently. If not, feel free, send me an email and let me know how you go with that. B's a little bit trickier, so I'm going to coach you through this one. Because there's an addition sign and there's a square root sign, we do not use the ClassPad calculator for this one because we don't use them in Year 9, but you will be using them in Year 10. So with this, we need to get smart with what we're doing on a calculator. So you're going to notice I'm going to use a number of brackets so that you do this all in one calculation and avoid having to round, which might give you a skewed answer. So step 1, first bracket. Inside that bracket, it's going to be 7.6 times 10 to the negative 3, close bracket. Now, when you're doing to the power of negative 3, please make sure you're using your negative and positive button. The negative positive button on your calculator normally has a little plus and a little minus on it. Do not use the subtraction key because that's when you get an error and it won't work. So you need to use the plus minus button, which is normally located around the equal sign on your calculator, depending on which calculator you have. So have a look for that one if you can't find it. Once you've got those brackets into play and everything that you need in that, you then put your plus sign, open up another bracket. Put your square root button in and open up another bracket there, because everything inside of the second bracket in here needs to get square rooted. So the 2.4 times 10 to the negative 2, close that bracket. We're saying everything inside of this bracket must get square rooted. Then close that final bracket that's on the outside. It looks a bit messy, but trust me, it does work if you can do this correctly. Then you press obviously your equal sign on your calculator, and hopefully you don't get an error message. You should get an answer of 0.1625. So we have an issue. That's not in scientific notation, so you haven't quite answered the question yet, and we need it to 4 significant figures. Step 1, scientific notation. Let's put it into that. Jump once, and we end up with 1.625 times 10 to the negative 1. Is the negative 1 on top of the 10 important? Oh yes it is, because we need to tell it to go in negative direction compared to when it's a positive, where we could have just left it as times by 10, but because it's a negative 1, we do need to write the negative 1. So you've now stipulated that it's in scientific notation. Does it fit the 4 significant figures? 1, 2, 3, 4. Yes, it does. Your job is done, and that is how you use your calculator. Please, boys, feel free to send me a message if you do have a question about anything that I've done in this exercise. But I would love to encourage you to give it a go and see how you go on your own. Because scientific notation, you felt very comfortable with. It's just now adding the significant figures part to it. I wish you all the best.